Yes, good morning students. Welcome to my channel. Today I came to you to explain the limits and continuity. So particularly from the limits and continuity, infinite limit I am going to explain. Infinite limit. Let us see these problems. Okay. Yes. So here these problems I am going to get within 1 minute I am going to get this one. So within seconds, this value is 3 by 2. This value is infinity. This value is 0. Okay, yeah, let us see how it is. Let me explain that a simple shortcut for this one. Okay, so if you know the simple shortcut, then you will be also able to do that within seconds. You will get the problem. Yes, what is this concept? Come on. So whenever the limit is given, limit x tends to infinity, the function f of x by g of x. When limit extends to infinity, f of x by g of x is given. Here I am going to get the three cases. So what is the first case? Is if the degree of the numerator is equals to the degree of the denominator. So what is the first case? If the degree of the numerator is equals to degree of the denominator, then what is the limit extends to infinity? F of x by g of x is. This is the coefficient of the highest power of the variable. The highest power of variable. So it is of the function f of x by. Similarly for the denominator, the coefficient of highest power of the variable of the g of x. That is about the case 1. Yes, coming to the case 2. Suppose if the degree of the numerator is less than the degree of the denominator. Okay, yes, what is the second case? Degree of the numerator is less than the degree of the denominator. In that case, its limit is 0. Then third case is if the degree of the numerator is greater than if the degree of the denominator. In that case, its limit is infinite. Yes, coming to this case. The first problem, limit extends to infinity, 3x square minus 1 by 2x square plus 1. In that case, what about the first case? Degree of the numerator is equals to degree of the denominator. Yes, degree is 2. In that case, what is your answer? The coefficient of the highest power of the numerator and from the denominator, which is 3 by 2. That's it. Very simple problem. Yes, coming to this one. Limit extends to infinity. Here, the degree of numerator is 2. Here, denominator is 1. Numerator degree is greater than denominator degree. In that case, what is the limit? Infinite. And coming to the third case, numerator degree 2 is less than the denominator degree is 3. Numerator degree is less than denominator degree. What is this limit? Is equals to 0. Okay. Yes, very simple thing. Very important model. So infinite limit. Come on, students, make a note. Yes, students, coming to the next model. Come on. Once observe these questions. Limit extends to 1 plus sin pi x raised to the cot pi x. Okay. So limit extends to infinity, 1 plus 3 by x whole power x. Once you see this one, by substituting the direct limit extends to 1. Sin pi 1, sin pi is 0. So and cot pi is not defined. So if we can get this form is the 1 power infinity form. Coming to this one. Limit extends to infinity, 3 by x, 1 by x tends to 0, 3 by x tends to 0, and this is 1 plus 0, 1 power infinity form. Okay, so all these problems are in the form of 1 power infinity. So whenever you will get the limit, so to get that 1 power infinity form, in that case, how we are going to solve this one? Let us see. Yes, so this is limit x tends to a, whatever the limit is, limit extends to a. F of x by g of x is in the form of 1 power infinity. Limit extends to a f of x by g of x, which is in the form of 1 power infinity. Yes, this limit is equals to e power. Limit extends to a f of x minus 1 into g of x. Yes, very important model. So whenever we are going to get that limit is in the form of 1 power infinity. That limit is equals to, that limit is, we are going to simplify in this one, e power limit extends to a f of x minus 1 into g of x. Okay, yes, coming to the first one. Yes, it is 1 power infinity form. Am I right? Correct. First of all, 1 power infinity form. Limit extends to 1. So this is 0 and this is infinite. I mean not defined. So which is 1 power infinity form. In that case, what I am going to do? So which is e power, right? E power. So limit, the limit as is, limit extends to 1, right? E power limit extends to 1. F of x minus 1. This is the base minus 1. 1 plus sin pi x minus 1 is sin pi x, okay, into g of x. So this g of x is as is, which is cot pi x, okay. Yes, then after the next step I am going to simplify this one. This cot pi x I am going to write as cos pi x by sin pi x, okay. Yes, these two get cancelled. Now applying the limit. Limit extends to 1. Cos pi x is cos pi, which is minus 1. So finally your answer is e power minus 1. Very simple thing. Yes, coming to the next problem. Yeah. So limit extends to infinity. First of all, is it in the form of 1 power infinity or not? Please check that, students. Okay, then only you can apply that one. Okay, yes, extends to infinity. 3 by extends to 0. It is 1 power infinity. Yes, come on. So which is equals to e power, yes, f of x minus 1. This thing minus 1, f of x minus 1, which is 3 by x into g of x. What is g of x? Is x. So your answer is eq. Simple. Yes, coming to third one. Limit extends to infinity. First of all, is it 1? Is it 1? Just in the video, in that videos, explain that about the infinite limits. The degree of the numerator is equal to the degree of the denominator. Okay, in that case, its limit is the quotient of the highest power, which is 1 and 1. Okay, so this value is 1 power infinity. So in that case, what I am going to do? Let us. Yes, come on. So which is in the form of 1 power infinity form. 1 power infinity form. Now this can be written as e power. Right, e power f of x minus 1, this total thing minus 1, which is x square plus 5x plus 3 by x square plus x plus 2 minus 1 into g of x. So what is g of x? It is x, okay. Yes, apply the same limit. Limit extends to infinity, okay. Then after simplify, it is the limit extends to infinity. Yes, come on. Simplifying this one, x square minus x square will get cancelled. 5x minus x, which is 4x plus 1. Am I right? Which is 5x minus x, 4x, 3 minus 1 by this denominator is as is x square plus x plus 2 of x. Yes, so you got the answer finally. This is e power. Yes, what is the degree of numerator? By multiplying with x, the degree of numerator is 2. Already the degree of denominator is 2. So whatever the degree of numerator and denominator are equal, in that case, when limit extends to infinity, its value is the highest power, the quotient of the highest power, which is 4. Numerator 4, denominator is 1. So whose value is e power 4. Okay. Yes, coming to this problem. Come on, students. You can try this problem in the same manner. First of all, is it 1 power infinity form? Come on. Limit n tends to infinity. 1 plus. Yes. Here numerator, there is no n power 0. Denominator n power 1. So totally this becomes 0. Numerator degree is less than denominator degree. It becomes 0, which is 1 power infinity. Please apply the same condition. Now you will get the answer. Very important model. So what is that? 1 power infinity form. Come on, make a note, students. Yes, students. So coming to this model, one of the very important model. Come on. So limit extends to 0. Cos 4x plus a cos 2x plus b by x power 4 is finite. In that case, what are the values for a and b? Yes, come on. Try to apply the direct limit. Limit extends to 0. What about the numerator, which is 1 plus a plus b, right? By denominator becomes 0. 0 by 4, 0. Okay, but here if the denominator is 0, the function is not defined. But clearly they have given that which is finite value. Which is a finite value. Yes, that means whenever you are going to get that 0 by 0 form, To get it is finite, we are going to apply the L hospital rule. Am I right or not? That is whenever you are going to get the 0 by 0 form. But here I cannot get the 0 by 0 form. Numerator is already 1 plus a plus b. Denominator is 0. Right? Denominator is 0. But to get finite, the numerator also must be 0. Then only I can proceed into the next step. Am I right? So that means when the numerator is equals to 0, then I got a 0 by 0 form, right? Then I am going to apply the LH rule. Okay, right? So in that case, I got one condition in terms of A and B, which is a plus b plus 1 equals to 0. Yes, now come on, applying the LH rule for this. So which is limit extends to 0, derivative of the numerator by derivative of the denominator, which is thus is minus 4 of sine 4x. So which is minus 2a of sine 2x, okay, by denominator is 4x cube. Okay, yes, now apply the limit. Numerator sine terms extends to 0. This is a 0 by 0 form. Yes, and again here we got the 0 by 0 form. Yes, and again apply the LH rule. Yes, which is limit extends to 0. Okay, come on, which is so minus 16 cos 4x. Am I right? And which is minus 4a cos 2x by which is 12x square. Now in this step, please apply the limit. Numerator is minus 16 cos of 0, which is 1, minus 4a cos 0, 1 by denominator. Yes, and again it is getting 0. But the limit is finite is given. That means we are going to move that in the next step. When we are going to move the next step, if it is and again 0 by 0 form, then only when we move to the next step, then only the function will be finite. Am I right or not? But what is the numerator value? By applying this one, what is the numerator value? Minus 16, am I right? Minus 16 and minus 4a. Minus 16 minus 4a, which becomes 0. Why? Because if the numerator becomes 0, then only we can move to the next step, then only the function will be finite. The limit will be finite. Am I right? Yes, in that process, already I got that a value, which is minus 16 is equals to 4a, which is a is minus 4. Yes, after getting a is minus 4, yes, and b is 3. That's your option. Right? This model is the very important model. Come on, students, make a note. Yes, students, one more problem for you. Same model problem. Limit extends to 0. A cos x plus bx sin x minus 5 by x power 4 is finite. In that case, what is the value of a? So please apply the limit. So denominator becomes 0. Denominator is 0. If the numerator is 0, then only we are going to apply that L hospital rule. Then only the limit will be finite. Are you understanding my point? Whenever the limit is in the form of applying the limit 0 by 0, then only we are going to apply the LH rule. Then the limit will be finite. Okay. Here denominator is already 0. The numerator, what about the numerator? Come on, apply this one. So cos 0 1, which is a, and this part is totally 0 minus 5. This is the numerator, but it is finite is given. The denominator is already 0. If the numerator is 0, then only it will be finite. I mean, applying the L hospital rule. Am I right? So what is the numerator? A minus 5 is equals to 0. Simply a equals to 5. Right? Very important model. This one. Come on, students, make a note. Yes, students. So one more model from the limits. So limit extends to 0. Root of 1 minus x square minus root of 1 plus x square by 2x square. Here also same model problem. This is the cube root of 1 plus sin x minus cube root of 1 minus sin x by x. I think you follow the traditional rule, that is rationalizing that numerator. Here also rationalizing the numerator, and here by using a suitable formula, standard formula for that. I think in that cases you may get somewhat difficulty. No problem. I will be there to make easy. Let us see how it is. So for that, you shall have to know that 1 plus x whole power n, binomial theorem. 1 plus x whole power n expansion, which is 1 plus nx plus the next term n into n minus 1 by 2 factorial x square and so on. neglecting the highest degree terms. I am going to neglecting the highest degree terms. Whatever it is, it may be 1 plus x whole power n or 1 minus x whole power n. I am going to write 1 minus plus or minus nx plus and so on, neglecting the highest degree terms. Okay, yes, come on, simplify that. Coming to the first problem, according to this, I am going to expand this one. The first one is limit x tends to 0. This is raised to the power 1 by 2. 1 minus x square raised to the power of 1 by 2. According to that, please you can expand, which can be written as 1 minus 1 by 2 of x square. The first term, am I right? Whole power 1 by 2. 1 minus nx. N is 1 by 2 here. 1 by 2 of x square minus of, and what about this one? 1 plus 1 by 2 of x square. 1 plus x square whole power 1 by 2. Here in that case, n value is 1 by 2. So 1 plus nx. 1 plus n means 1 by 2 with x square. 1 by 2 x square by denominator is 2x square. Yes, come on, simplify. So this is equals to limit x tends to 0. So 1 minus 1 get cancelled. Okay, yes, so this is x square by 2 minus of x square by 2, right? So which is minus x square by 2x square get cancelled, whose answer is minus 1 by 2. Very simple. Okay, yes, coming to second problem. Yes, coming to second problem. Here I am going to write. It is also 1 plus 2x whole power 1 by 2. Come on, expanding according to that binomial theorem. So I think I can write like this, which is limit x tends to 0. 1 plus 2x whole power 1 by 2, which can be written as 1 plus 1 by 2 of 2x. Am I right? This is raised to the power of 1 by 2. 1 by 2 into 2x. nx. Okay. Yes. And minus of, and what about this one? 1 minus 1 by 2 of 2x. Am I right? 1 minus x whole power 1 by 2. 1 by 2 into this term. Okay. Yes. By this is sin x. Can you see that next one? So which is limit x tends to 0. Yes, limit x tends to 0. 1 minus 1 get cancelled. So which is x minus of minus x. Am I right? Okay, which is plus x, which is 2x. 2x by sin x. Here we have a direct formula, standard formula. So which value is 2? That's it. Yes, come on, make a note and try this problem. Students, very important model. Come on, make a note.